Hey guys, so welcome back, and today we have another question by Ava. Give this question a read actually, and I actually recorded this. You'll see my YouTube upload, but I forgot the sound. Once again, guys, so give this a read. Pause the video after you read this. See if you can calculate it. Okay, and I'm just gonna quickly speed through it again because I have all the material already. Firstly, okay, we have a cylinder radius 8 and height 30. So firstly, this is the oops. This is the properties of the cylinder, right? And this is the property of the rectangle. If you've read it, I'm assuming you read through it. The rectangular prism, okay? Calculate the height the water level rises up the cylinder. So what is it saying? We have a height here and we have a height here. The original was 15 centimeters. The new one will rise after we submerge, like a brick or like a rectangular prism. And the new height is here. What it wants us to find is the difference between these two heights. So like this difference, okay? Great. So how do we find the new height? Firstly, we need to, there's two ways to solve this. I acknowledge. The first one is Archimedes' principle, which directly deals with displacement. If you don't know that, don't worry. We'll do something else. Solve using displacement theory, right? So firstly, the theory just states that if you have 50 mils of water and you submerge a cube that is, let's say like a ball bearing, like a steel, it's not ball, I can't draw a ball, a steel cube, 1 cm by 1 centimeter by 1 centimeter will displace 1 cm cube, right? So the water level will rise to 51 milliliters, okay? Because 1 cm cubed is equal to 1 mil. Anyway, it should make a lot of sense. If you jump in a water bath, it will rise the same amount of volume your body displaces, right? Okay, so the volume of a rectangle, firstly, we need to find the volume of the rectangle, okay? 864. And how do we find it? They give us dimensions of the rectangle as above. Now, recognize when the rectangle is added, water volume will increase in accordance to the rectangular prism's volume. Good, so this is done as well, okay? Does that make sense? So, it should make a lot of sense. You submerge a tissue paper roll. However much volume the tissue paper roll displaces would be reflected in the water volume increasing, right? And now the water volume, they give us 8 as the radius, right? So from here to here, 8. It gives us the height is 15. So volume, volume of a cylinder, what is it? Right, it's the area of the base, which is pi r squared times height, 15. And that's how we got pi r squared and height. So this is r squared, this is height, this is pi. Done. Okay? So we've solved for all of this. This would be the water volume. I have not put this into the calculator yet because, pi is we call it an irrational number. So, not rational, irrational, it's a third. So it's an infinite number. I will continue on forever. So once you multiply that by 8 squared and 15, you get a never-ending number as well. Don't solve it yet. Otherwise, you'll have to round off and you get inaccuracies. What we need to do now is we need to recognize that the new volume of the new sphere, okay? This sphere, right here, this, not sphere, sorry, new cylinder is going to be a new volume. And the volume is going to be the volume of the water from before, as stated here, and the volume of the rectangle. So you add them together. 864 is just from here, okay? And this is from here, right? Now you add them together, and that should be the volume of the new cylinder. That was the tricky part. Okay, if water level rises, new cylinder of water displacement should equal to V pi r squared h. So same thing, it's still a cylinder, but just now recognize that the new volume is what we said above. It's pi times r squared times h plus 864. And this should equal to what? Okay, it should be equal to still pi times r squared times h, right? So what is pi? Pi is just pi, right? It's not a variable. It's just 0.14159. R squared, does the radius change of the new cylinder? No, it does not. The height changes, but the radius remains to be 8. So it will be pi times 8 squared times h. We want to solve for h. So you just do that. Easy algebra. Solve for this side first. Then you divide both sides by this. Okay, it's normal algebra. You should be able to solve this. And you get the new height. Now remember in the beginning we said the question asked for the difference or the how high the water level rises. Okay, so if it's rising, what's the difference? We want to find this, right? So we want to find the new height subtracted by the old height, which was 15, and you get the difference in height. So the height of the water rising is equal to the new height minus the old height, and that would be your answer. I didn't solve this because I don't have a calculator handy, sorry. But that would be your answer, okay? And remember, try to put it into 2 decimal points. Good job, guys.